So yeah, absolute pleasure to be here to talk to you today. Hello, my name's Simon. I'm from the UK. I'd love to hear where you're from, so please ping in the chat and I'll say hey. I'll give you a call out. But I'm going to jump straight in because I think I have about 30 minutes. So is that right, Edson? I have about 30 minutes, so I'm finishing at about 1:15-ish. Is that correct?
Yes, 30 minutes.
30 minutes. Okay, cool. I'll try and do that. Hey, good to see you, Nikolai and Raphael. This is Stranger Danger. So let me go this full screen. Oh, maybe I can't give shout outs because I'm going onto slides. Rubbish. But hey, let's go ahead. I'm going to do a few slides. Slides are boring, so I'm going to jump into live hacking as soon as I possibly can. This is called Stranger Danger. It's about how we find security vulnerabilities in our applications before they find you, before someone else finds them. My name's Simon Maple. I run the DevRel team here at SNCC. At SNCC, we are very fond of creating developer solutions for security. So security solutions for developers, as it were. How do we get developers being more secure and using, doing security focused activities as part of their usual day job? I've been in Java for well over 20 years now. And my background is as an engineer for IBM, working on WebSphere and other amazing middleware products like that. I also run the Virtual Jug, the London Java user group, and I've got a couple of awards there. If you wanted to reach out, please do on Twitter at SJMaple. Okay, let's start with something that hopefully everyone is aware of and absolutely loves, I'm sure. DevOps, it helps us deliver value very, very fast. It allows us to write some code in an IDE and push that to production later that day, later that hour. We can do it very quick, we can do it often, and we can do it in a predictable way. However, when we do things like that, there are a number of other things that don't fit that model, one of which is security. And that's why DevSecOps is a wonderful, incredible buzzword, which was created and loved by many. What are the problems, though, that something like DevSecOps solves? Well, with this speed up of people wanting to push code to production often and quickly, how does things like the traditional security audit, how does that fit in? We do that, from what I understand, once every 25 years, where the whole security team come from their dungeon, they come to the developer and they say, no, you cannot push this because we have 100 vulnerabilities that are open if you push that. So what happens is the developers, they end up hating the security team. The security team end up hating the developers because they put in all these shiny libraries. How do we solve this problem? Well, DevSecOps is similar to that DevOps mentality where we try and pull these different silos, these different teams together so that security is made a first-class citizen in that pipeline. So every time we push, we have security considered, we have security tests running, and we know when regressions occur because customer data could be compromised. Yes, Equifax know that all too well, as do any Equifax user. This was one of the headliners that has made the news over the last few years. And realistically, the reason that this breach occurred and so many millions of US customers had their sensitive data breached was because of a popular library called Apache Struts. And Apache Struts, as we know, is an open source library. One of the reasons why open source libraries are so useful is because everyone can just use them and adopt them and grow based on them. One of the horrible things about open source software is that when there is an issue, whether it's a bug or a security problem, that bug or security problem exists in many, many different places. Now, that's not a criticism of open source. That is almost like it's an issue that exists because of the popularity of open source. Now, when we think about something like Struts, we can see that when the Apache Struts vulnerability that affected Equifax was announced, it was mid-March. There was the spike in the number of people that were attacked, the number of attacks that occurred rose significantly, and this is because a exploit code, test code became available, and anyone could just run this test code. And I'll show you how anyone could run that test code because I'm about to run it now. What I've got, if I come back here, Maximilian, lots of Star Wars stuff. Yes, it's my Millennium Falcon and my ATA, and these are legit toys from the 70s, which I got. Hey, Mark. Hey, Uday. Hey, Labina. Hey, Vijay. Good to see you all from lots of different places. So, sorry, I'm getting distracted. Right, let's go to my browser. From here, what I'm going to do is I'm going to show you this to-do application. This is a very simple to-do application. As you can see, I can create a to-do. Let's buy my wife some flowers. She definitely deserves them. Flowers. There we go. Let's add a due date. of the 14th of January 1970. I better make that high, I guess. Add that. There, we have an ID of 11, we have a title, we have a due date, etc., etc. If I click on About, we can see all the different tools that we use here, all the different frameworks. We're using Struts at a vulnerable version. We're using Spring at version 3.2, a very early version of Spring. We're using Hibernate because we love to make poor life decisions. So here, because we know we're using a vulnerable version of Struts, we're going to actually exploit that now. So I'm going to come back here, and on this page here, I'm going to show you, not in that directory though, let's go back one and into my exploits directory. I'm going to show you this headers file. Okay, in this headers file, oh no, that was not what I wanted at all. In this headers file, this is a header that we're going to be sending on a request to my vulnerable struts endpoint. We'll see a content type straight away. That content type is illegal. So we're going to go straight down into an exception path once we hit this endpoint. Now, it is illegal because of this percent. It is illegal because of this percent and brace, and there's also a brace at the end there. Now, when we go through this exception path, we'll go through a library called OGNL, which, as one of the things it can do, is it evaluates certain pieces of text to give us a richer output or for our error messages, and that's how one of the ways it can be used. Now, it's going to evaluate anything within this percent brace a piece of text, which is great because we've got a bunch of code that can execute here, of which we're going to create a new process builder, passing in commands. The commands we're passing in are bash, and bash is going to run a command called cmd, and this is just in big letters command. We can substitute this in just a sec. So let me go to my little crib sheet here. Let's grab this one, and I'll walk you through this as we run it. So I am catting that file, that exploit headers file that I just showed you. We are doing a string substitution on the command keyword there for env. So this is going to print out our environment variables. I'm just going to curl this to an endpoint. That endpoint currently is set to my local host, but instead I'm going to point that to bigger. I'm going to point that to this, and this is my to-do application, which is actually in fact running on a Heroku app environment. So let's curl our Heroku app application, that to-do list, and now that's all we're going to do. We're going to send just a plain curl request, get HTTP request over to that endpoint. We're setting up our header so that we're passing in an illegal content type, which evaluates, OGNL will evaluate a piece of that code. If I hit return there, hopefully, after setting all that up, there we go. There are our environment variables. You can see our Java options, you can see our path, you can see our working directory, our Java home, and a whole bunch of other stuff. And believe you me, some people, not anyone on this call, I'm sure, but some people will put sensitive information into their environment variables. And an evil person like me, evil laugh, will pick that up and potentially do some nasty stuff with that. At this point, I have execution rights. I can execute commands of my choosing, and that will run under the process and use the privileges of the process, of the user that is running that process. And in this case, I think this is just a Tomcat server or something like that. So I am now running under the user of that Tomcat service, and I can now execute whatever commands I can under that user. So that was the exploit. Let me come back here, and we'll go through a couple more slides, and then we'll start hacking again. So, lo and behold, this is your application. We have a very small circle in the middle, and that's your code. That's the code that you write in your IDE. And then we have this huge amount of code around the edges. And this is all your open source dependencies. And this is very common to see your code being the much smaller piece of your application. And it's because we leverage so much amazing open source stuff. So here's a great example. And why don't I ask you, if I can, in fact, I can't see it just now. That sucks. But let me ask you to put your answers in the chat as I go through this. There are 19 lines of code in here. There are 2 direct dependencies. And this is just an application which grabs a file and stores it in Amazon's S3. Now, I'm going to ask you a couple of questions, and I want you to put those answers in to the chat. And I can't see it right now, but as soon as I stop this presentation, I'll be able to see that, and I'll be able to maybe give a prize to someone. Or maybe it will just be some kudos. How many indirect dependencies do you think we have on this application? So we have 2 direct dependencies. How many indirect or transitives do you think we're going to have on that application? So these are the dependencies that each of those 2 dependencies will pull in. I'll give you a quick second to put your ideas in there. The answer is 19. So only 17 dependencies. Now, I can't see the answers right now, but I'm sure because this is the Java track and not the JavaScript track, everyone's going to be trolling on JavaScript, and they're probably putting in millions, hundreds of millions, trillions maybe, but it's just 19. So it's not as bad as it could be. However, now the next question, how many lines of code do you think we're going to be deploying? Is it, this is the lines of code in our application there for 19 lines of code in our IDE, plus the number of dependencies that we have. So how many lines of code are in all of that? Now, typically, I'm going to guess right now that some people are putting maybe tens of thousands or a certain number of thousands. Some people might go crazy and say, let's put 10 million or something like that. The answer is in between. It's about 191,000, so almost 200,000 lines of code. Now, the key here is don't just look at what's in your IDE. The application you deploy is 200,000 lines of code here, where the application you see is this 19 lines of code. So be very conscious of what you're deploying. And of course, you're not necessarily going to go through all of those lines of code. They may not all be active in endpoints, but we have to be very conscious of what we're deploying, because what we maintain and what we have to secure is what we deploy. It's not the code in our IDE alone. How many more slides have I got? Let me see. I'll go through. Oh no, I don't want to go through too many slides. Let me go through this one. How do we then go about fixing this? So we know there are vulnerabilities. We know we sometimes introduce them ourselves. We know sometimes we introduce them with our pull requests. We know sometimes they're introduced in existing code that we've deployed into production. We need to know and test at every stage. And the key thing here is testing early. This is like the typical shift left, or giving that responsibility to the developer to make sure they're empowered enough to test their code before they push to a repo, to maintain that when they do get to the repo, tests are made so that people can understand if they're introducing new vulnerabilities and can't regress. And also so that when we get to production, even if today there are no known vulnerabilities in our code, in our open source libraries and open source projects, even though there's nothing there today, what if there's something that is found tomorrow or a week later or a year later? If we're not going through this pipeline, who is testing for that, and how do we know that these new things have come around? So these are some of the things that when you think about, I'm happy to I mean, you can see some little SNCC logos here. I'm happy to talk about this offline as well if people are interested in learning about how SNCC can do that. But let's hack. Let's go terminal. So I'm going to jump to, here we go. Oh, actually, let's have a look at what people thought. So actually, so not too bad. 20, 54, 42, 14. Leap from Sebi, nice one. 200 indirect. So of around the same kind of number as we had. 1,500 lines of code, 29K from Osama, 1,800, 54,000, 100,000. So yeah, everyone was pretty low. Sebi with another ridiculous answer. That's awesome. I love it, Sebi. Okay, that's cool. Right, let's jump to another application. This is actually a Node application. Two reasons. One, because it doesn't matter too much. It's a vulnerability is a vulnerability, and we're just going to exploit a particular vulnerability here called directory traversal. And secondly, it's actually more fun to hack Node because it's easier. Well, that's a lie, but that's what I say from a Java background anyway. Okay, so this is a to-do list application. I'm going to buy some milk. That's my to-do. There we go. There's my to-do. There's my little to-do. Let's buy my wife some more flowers. Buy wife flowers. Add these, regular to do. I can also click on about, the bestest to do app ever. Just an about page which has been served from us as a static file. This is all fine. Now what I'm going to do is I'm going to show you how we can scan this. So I'm going to do it from both sides, the blue side as well as the red side. So let's go ahead and scan this. I'm going to go into my integrations. This is just using SNCC, but you can use whatever you wish. From here, I am going to go into my repo, and I'm going to open up Goof. And what we're now doing is we're connecting to GitHub. We're looking at the Goof application from GitHub, and we're now going to try and find the manifest files which are in that application. From the manifest files, we'll be able to build up a dependency graph, and we can see where vulnerabilities exist in that dependency graph. So if I was to view the log here, this shouldn't take too long. In fact, it's already found the JSON package, so it's recognized it's a JavaScript node application, and any second now, and it takes literally a few seconds. We can view the project. In fact, and hopefully see the snapshot here. Here we go. Okay, so we can see the number of dependencies, and this is a great way of looking at your bill of materials. You can see direct dependencies, transitives, and where your vulnerabilities exist. But what we want to do is look at a specific directory traversal. And a directory traversal, here we go. A directory traversal vulnerability is one whereby we have maybe access to a specific vulnerability, and we are looking at how we can potentially break out of that. We have access to a directory, and we're looking at how we can break out of that directory into potentially a private directory or something like that. So how are we going to do that? Let's have a look. This is coming from the ST module. So the ST module is one in which serves static content to users. So let me go back over to the application. Let's ask in the comments, how are we going to hack this? Let's do this together. We want to hack this. It's a directory traversal. Any ideas of where we even start? Which part of the application do we want to attack? Which part of the application do we want to hack? So yeah, please do ping in the comments as to which page or how I should go about doing that. And I'm not going to hack this. You're going to hack this. So let's try and do this together. What do you think? Okay, nothing just yet. So there's nothing in the there's nothing I haven't shown you. It's these two pages, the about page and this page with looking for ideas in the input box, in the input field, in the text box. Okay, what should I do here? Inject code into the data to be evaluated, and dot slashes. Okay, dot slashes. So dot slashes in here maybe. Dot slash to the URL. Okay, now we're getting somewhere. So which URL? The home page or perhaps our about page? If we look at our about page, maybe our about page. Maybe our about page is a little bit more interesting. So if we look at our about, it's got a directory structure in there. So if I come back here, let's go to a fresh page and let's curl it. Okay, so there's our There's our about page. There's our about document. We can see this is the URL, and we want to do a dot slash, I presume. So add Chris Holmes is saying add dot slash to the URL. So something like this. Okay. Hopefully this is going to work. Let's see if this works. Okay. So we can see. This is just some HTML. We can see buy my wife and flowers. We see the dot slash. We see buy milk. This is actually the homepage, goof to do homepage. So what's happened is ST is a real library. Okay, it's a real library that recognizes we're trying to do a dot slash. So we're on the right lines, but we can't type dot slash because it is looking for dot slash. Okay, Mark Harding, awesome. Mark Harding has suggested replace with %2e instead of a dot. Now. %2e is, as all great hackers know, well done, Mark Harding, is the URL encoding of a dot. So if we do a dot as URL encoding, what we're suggesting here is that ST isn't going to be looking for %2e, and it's not going to be normalized because we're sending curl. So if I do this, bang, we have a directory traversal. We can see that because we're outside of the public directory. And I'm just going to quickly go back to my browser. And in fact, while I'm going to show you back in the browser, think about what you want me to do next. Think about as an attacker, what would you do if you just broke in and started looking at this? Where would you want to go? So think about that just for a second. In the meantime, what I'm going to do is from here, I'm going to do exactly the same thing with %2e /. And by doing %2e here, we actually get back to the homepage, and that is because my browser normalizes the %2e. It turns that it decodes that back into a dot before sending that. Okay, and as a result, the ST directory does see the directory. So it does see the dots, and as a result, knows it's a directory traversal. So Marco wants to do something crazy. Look, rm-rf, the DB directory. So what is this? Let's go back to our vulnerability. Let's go back to our vulnerability and see what our vulnerability is. So if I was to come back here, we're in directory traversal, right? So if I was to go into directory traversal, and let's click on more about this issue, we can see this is our CVSS score. So our CVSS score is the score out of 10 based on the how the vulnerability, or how by exploiting this vulnerability, how much pain you'd get based on what it can do, what kind of build up you need, what is the attack vector, etc. And you can see that the scope here is unchanged. So what unchanged means is if someone were to exploit this, you're effectively read only. You can't make changes to the end system. So this is just as a result of us doing this, we can only read. So that's a good idea, Marco. But what can we read? Well, let's have a look. In this directory, we've got a whole bunch of stuff. So we could have a look at, why don't we have a look at the app.js? See our source code here. Maybe we do something instead. Maybe we have a look at our package, package.json. And look, here's all our other direct dependencies, which we could potentially try and find other vulnerabilities to. So maybe we could see something like Humanize MS is an interesting one. Humanize MS has a, let's have a look at it. Humanize MS has another vulnerability in it. Oops, did not mean to do that. Humanize MS. Let's do a quick search on Humanize MS. Humanize. It's got a redos. It's marked, fresh, marked, moment, braces, marked. Humanize MS. Okay, Humanize MS pulls in MS, which pulls in and that has a regular expression directory traverse. So regular expression denial of service. So let's try and hack this. What is this first of all? Well, a regular expression, we know what that is. A denial of service, we know what that is. A regular expression denial of service is by computing a regular expression which takes so many cycles, we are effectively taking up the resources so much. Could be computational, could be something else, but we could cause a denial of service on that thread. So let's try and cause an exploit right now. If I go back here, what you'll see is if I was to say buy milk, but this time in 30 seconds, no, let's say, 30 seconds, no, let's go 2 days. What it's done is it's parsed that. It recognizes I'm doing in followed by a time, and as a result, it's turned that into milliseconds, so I can maybe do something like a reminder or a notification, and then it's just representing it here in braces as 2D. So what I could do is provide a string which causes this thing called a catastrophic backtracking. And catastrophic backtracking is where I would do something along the lines of that. And this is a string whereby I can type a pattern like A and a number of Bs, and that will match. However, if I type A and a number of Bs and then a C, this number of Bs can be matched in a number of different ways. It could be matched by the plus, or it could be matched by the star, or a combination thereof. So it could maybe do the first couple with the plus, the next couple with another plus because of the star, and so on. We don't know. But as soon as it gets to a C, some regular expression engines will backtrack and will try and find all permutations of this B plus star, whereby it'll try and match these Bs and see if we can find a C at the end. Of course, that will never happen, but it will try and exhaust all those possibilities. And as the number of Bs in here grows, the number of steps exponentially grow that we need to exhaust. So let me come back here and let's actually try that. So what I'm going to do is I'm going to quickly type ms2. I'm going to, just to save my typing, I'm going to try and send this. I'm going to echo some content. It says buy milk in, and then we're going to print out 60 character 5s minutes. Okay. And we're going to send that across. So I execute that. There we go. Buy milk in, and there's 65s minutes. Okay. Is this going to actually cause a denial of service? Well, let's ramp this up to 600, 6,000, 60,000. Run that again. It comes back very, very quickly. Now, if I was to come back to my refresh this page, you can see the requests are coming in just fine, despite that being infinity days. The requests are coming in just fine. However, the problem here, the reason we're not getting a delay, is because this actually resolves first time. It finds the match. What we need to do is stop it from finding that match. And we can do that by just adding a typo at the end. So now it has to parse through all these fives. It gets to minutes, but because there's instead of an S here, we're replacing that with an A, it's going to backtrack through all of these fives. So if I hit return there, we hang, we pause. I'll come back here and I'll type hello, and I'll hit my keyboard hard. And despite it making a loud noise, nothing happens until which time as that times out or the number of permutations complete. And any minute about now, that thread comes back and it executes. It goes to all those other requests. So regular expression denial of service through a denial of service through a regular expression being way too long. Ways you can fix this, of course, you could look at the string you get, and if your string is anywhere near this size, you would make sure you can't you won't parse that. You would not even look at it. Another way is fixing the actual vulnerability by going up to a newer version of your library. Now, in this case, the vulnerable module is MS. The library which is pulling in MS, so this is our direct dependency, is humanize MS at 101. The fix is to upgrade humanize MS to 102, and this is the minimum version which pulls in a fixed version of MS. Okay, so now if I was to go in and click fix this vulnerability, the idea being this is going to now send a request back over to GitHub, and let me just click now, open a fix pull request, and we'll see this working nicely in conjunction there. So I click on files changed. You can see the file that we changed there, 102 versus 101. What you'll also see is a number of other things in that I am making checks on all of my changes to make sure our delta doesn't get affected. So are we introducing any new changes into our repository based on this pull request? And those are both license changes and SNCC in terms of the vulnerabilities. So we can do this at various stages. Here I've shown you the repo. You can also, if I was to come over here maybe and say let's do this via a repository, here is that Java Goof application which I've just got in IntelliJ. I've done a quick scan. You can scan whichever Maven project you want, and you can see all the vulnerabilities here, and I can click on one of these to say let's upgrade a specific version. The suggested upgrades are always given here, and I can just kind of like come along, click, and it'll show me which version I need to upgrade. So this is super important, but I think there are a number of other things other than tooling which are extremely important, and that are things like changing that mentality to pulling security in earlier in the development environment, having security mavens that exist in your development team, so that there are individual developers that recognize and understand that you get you get much more experience and expertise in the development stage. Also, code reviews are absolutely key, making sure that when you go through a code review, you're not just looking at code that you're writing, but also code that you're pulling in. One other thing actually I'll show you is if I go to my pull requests, one other thing that's really important, and I'll show it in SNCC here, but you can do this however you like, is what happens when you get a vulnerability that is that's existed for ages in your production environment, but that hasn't been known. Well, one of the things that we can do here is raise an automatic pull request. So this is an automatic pull request, which you're just kind of like running in the background that's happening automatically. You don't actually have to put anything through the pipeline. And what you'll see here is a file change that has occurred. This is the smallest version jump you can get, which includes this fix. And this is that the project has had vulnerabilities that couldn't be fixed or couldn't be patched because no upgrade was available. But now new upgrades have been made available. And as a result, we automatically send a pull request which can patch that. Very similar if it's a new vulnerability that wasn't known previously. So there's a whole bunch of other things like this that can be done, but it's all about making putting security into the developer flow and the developer workflow. That's everything I've got to say. I hope you enjoyed. I think I'm pretty much at time now. I hope you enjoyed. The session, and happy to take questions if there are any.
Simon, you are perfectly on time. Thank you very much.
Excellent.
Yeah, British as usual. And we have a question in the chat, like, sure. Yeah, the last one.
Question: Snick versus White Source Bolt. Okay, yeah. So White Source, again, an SCA tool. So now we know, right, Sebi? That's what Snick stands for. Yeah, White Source is another tool that does similar things. From our point of view, we have the way we work is from a very developer first oriented way. So everything that we do is focused on developers, and I think if you was to try both together, you will, enjoy the Snick way of working, the way it allows you to do things in a much more kind of like developer friendly way. We also have, certainly in my opinion, and also a number of other people who are using our database. We have a number of major groups using our database. We have an entire security team which really do some amazing work in both finding new vulnerabilities and also working with vendors that do that. So I think I would say our vulnerability database is more complete in that sense as well. But I would say, it's all about user experience. And I think you'll find if you use Snick, you'll see the differences. It's very much more like would you use IntelliJ or would you use Eclipse? It's all about that user experience. So give that a go, and I think you'll find there's significant difference in terms of the usability.
Amazing. I couldn't see any more questions in the chat.
Mm-hmm.
So, well, Simon, I was amazed by what Snick can do. So yes, maybe I should run it on my projects.
Absolutely.
If they are vulnerable.
Absolutely, and yeah, if you want, it's entirely, we have paid plans, but it's entirely free just to go ahead and sign up, and you can use that both at as I've shown in the repo, as well as with Docker scanning. We're already integrated with Docker on Docker Desktop and things like that. So you're more than welcome to kind of like try all that out for free and use that month on month. So please do go ahead and try it out.
Oh, awesome. So, in behalf of the DevNation organizing team, thank you very much, Simon, for this amazing presentation, and I hope to see you soon in the next opportunity.
Thanks very much. A pleasure to speak. So thank you for having me.